Hello friends, in this video we will solve a problem which is related to the motion of projectile on an incline. So in the question it is given that a person is lying on an incline of angle 30 degree and he now tries to hit the target at point P with the help of a bullet and he is firing the bullet at an angle of 30 degree with respect to the incline. Now the time taken by the bullet to travel from point O to point P is 2 seconds. Now with the help of this data, we have to find the initial speed of bullet and the value of x. Okay, so now let us solve this problem. I have already written the diagram for solving this particular problem with all the conditions that are given. Now I am assuming that from point O to point P, I am assuming that the bullet has traveled along x direction a distance equal to L1 and a distance equal to L2 along y direction. So it is evident that for solving this problem, I am about to consider this direction as positive x and this vertically upward direction as positive y direction. So if I am going to resolve the velocity of bullet in x direction, the initial velocity of bullet in x direction can be written as for x direction, the initial velocity of the bullet is ux, which is equals to u cos 60 degree, that is u by 2. Since we know that acceleration in x direction for this case will be 0, as I am assuming x direction to be perfectly horizontal. Now when time is equal to time of flight, which is given as 2 seconds, or let us for a moment write it as time t, the displacement of the bullet in x direction is equal to L1 that I have assumed in the diagram. So from here I can write that L1 is equals to u by 2 into t. Let us call this as equation 1. Now applying the same process for y direction, I can write initial velocity along y direction will be u sine 60 degree, that is root 3 u by 2. Acceleration in y direction will be equal to minus g. When time is equal to t, the displacement in y direction is equal to L2. So again applying second equation for y direction, the value of L2 will be equal to minus 5t square. Let us call this as equation number 2. Now if I divide equation 2 by equation 1, on dividing equation 2 by equation 1, I will get the value of L2 by L1, which is equal to the whole divided by ut divided by 2, and this value has to be equal to tan 30 degree, that is 1 by root 3, and this can be derived from this particular diagram. This conclusion can be derived from this particular diagram where I can directly see that the value of L2 by L1 will be equal to tan 30 degrees. Okay, so now substituting the value of t to be equal to 2 seconds, since this data was already mentioned in the problem. So if I substitute the value of t equal to 2 seconds in this expression, I can directly solve for the value of u, and on solving this equation, the value of u comes out to be equal to 10 root 3. Now with the help of this velocity, I can now find the value of x, that is the range along the incline. It can be indirectly found by first finding the value of L1. The value of L1 will be equal to 10 root 3 by 2 into t. So this value was written with the help of equation number 1, where I have substituted the value of u and t to find the value of L1, which on solving will be equal to 10 root 3. Now with the help of basic trigonometry, I can say that if this length is L1, this angle is 30 degree and this range is equal to x, then with the help of trigonometric identity, I can say that the value of L1 by x will be equal to cos of 30 degree. So if I substitute the value of L1 in this expression, I can find the value of x. This value of x on simplification will come out to be equal to 20 meters. So now I have my two desired results: initial velocity as well as the range along the incline.